record with 125 plus journal publications. Sir, it last slide. It is now my privilege to invite Professor D.K. Lobia sir from JNU, New Delhi, an eminent researcher with over 25 years of experience and 125 plus publications. Sir will be delivering an expert talk on deep learning and the human brain, which is highly relevant in the context of artificial intelligence, neuroscience, and interdisciplinary research. Sir will request you to kindly address the gathering.
हेलो आवाज आती है ना?
यस सर
तो मास्टर लोग बोलेंगे तो कैसे जाएगी बेटा माइक कीजिए। Okay, thank you for inviting, and let me start without wasting time. This title I chose because I thought there is a misnomer or misconception that many thought that as if neural networks are the way to represent human brain. That's where I thought let me put this. So I will talk a little bit of this human brain and then how the neurons in the human brain works, and then how it correlates with the deep learning, and then where we are now. That's what the whole question is. Let me talk few things now. See that when you study neural network, artificial neural network, and what we see is we see that a neuron sends an output to the other neuron, and which we multiply with the weights, and then it goes into the other neuron. Then we have an activation function, it makes nonlinear, so on and so forth. That's how it goes. But how does human brain works? Does it works in the same way or not? And one important part is the neurons in the human brain works in a manner that a neuron generates a spike, quick, instantaneous. If you show it mathematically, it's a Dirac delta function, right? It will generate an impulse and then vanishes and slowly, right? And then the question comes, that is what we call action potential. That means the potential difference inside the neuron and outside the neuron makes a potential difference that excites the neuron to generate some input. And that potential difference occurs because of some stimulus. If I see something, some input goes and the potential difference changes, and neurons get activated and generate some spike and sends to the next. That's how the human brain works. And then the entire question comes, how can we understand the process of spike generation? That is one question which is the same as we do in the artificial neural network. It is different than how the spikes are generated in the human brain. And then how this information, whatever information we see and we pass from neuron to neuron in the brain, and how do you understand that what information is passed through between the neurons? And important part in the human brain is a network of thousands, random network of thousands of neurons. Thousand is not only one thought, thousands is thousands of thousands of thousands that way, right? And coupled together in a random network. That means it's a very complex and large number of neurons. And then if you look at this diagram, I put an interesting diagram. Let's go. If you look at the spike is generated here quickly, and then it comes down. So the moment the potential between the outside neuron and inside neuron changes, then something happens and a spike is generated. And if you look at this spike, I have represented a delta function, and then it comes down. And if you look at zero, it goes down below the zero. Zero means resting. When the neuron is not doing anything, it is at resting. And at rest state, it has a potential of minus 65 millivolts. A human neuron has a potential of minus 60 millivolt when it is at rest doing nothing. If you look at artificial neural network, we add a bias. The bias comes from an expression from the human neuron because human neurons are not at zero. They have already some potential. If some potential comes, you add this minus 65 to that. That is the bias what you add in the artificial neural network. So the inspiration from the human brain to artificial neural network comes because of that. Every neuron you add a bias. करते ना AI में आप, it is one of the region which has inspired from there. So there is not one. And it goes, when it comes down, it goes below 0. And then gradually, exponentially, if you look at it, goes below 0 and then comes to 0 exponentially or slowly. And the reason being, is beautiful reason is that, look at the beauty of the human brain. This happens because you cannot quickly generate the second spike. There has to be time. So, एक spike और दूसरी spike के बीच कुछ time होना चाहिए, so that the neurons respond to. If it has a spike, उसके reaction कुछ करना पड़ेगा. Say for example, how much time a neuron will take when you see something? It takes around 400 milliseconds a human to respond to some stimulus.
Because this time from negative to getting back to 0 is at that time.
Yes, that time is a refractory time.
Cooling time.
Cooling time. So that the next spike will be generated after some time. Quickly, if you generate quickly, neurons will not be able to respond.
And just to show this, we have shown this from the negative scale.
Yes. So that is the beauty of human brain is. And if you look at this, so now the brain activity is now one of the important points. If you look at neuron connections, these connections and the transmission of message show some activity. If some activity is happening, therefore there are connections and information is being transmitted between them. So how does this connectivity show some activity, and the vice versa as well, how the activity is represented by some connections of neurons, right? That's important question, and to address those, now you need a lot of mathematics, physics, biology, everything has to be together in computer science. That's what a field called computational neuroscience has emerged because of that. But today I'm not going to on that much, but few things I'll discuss. This diagram, I'll not go. This diagram everybody knows. And I put it simply, it's a beautiful diagram. Why I put this is, look at this long axon. आप AI में पढ़ते हैं कि axon है. But look at this axon has a beautiful thing is, if you look at over this, you find these big layer called seed, myelin seed. And the important point is the conductivity, the way the neuron signals travel is 10 meters per second. If you look at the way the communication signals travel, 10 meters per second is a very slow speed. But this outer layer, look at this, is helping make it faster. And with the age, this outer layer diminishes. This is one of the reasons for Alzheimer's. Because this outer layer, this seed, myelin seed gets deteriorated over the period. Therefore, the speed gets slow. Right? This is one of the reasons. I am not saying this is only the reason. And second point, look at these gaps again. These gaps are also to amplify the signal. See, when the signal goes, it also gets attenuated. That's the general characteristics of a signal. So these cut points are again a region for to increase the potential and increase the what's called amplify the signal. See, look at the beauty of the human brain. Repeaters, yes, right, and that makes you to work faster. And if you look at those points, the okay, leave this. If you look at the number of neurons, what I am saying is 10 is what 12, and each neuron is connected with 10 is what 4 neurons. एक neuron 10,000 से connected है, तो how complex the whole neural network is. And therefore it is difficult to map whatever now आप कोई भी NVIDIA system कितना भी GPU का ले लीजिए. You cannot deal with such a complex network of billions of connections. You cannot simulate at all. अभी 80,000 कनेक्शन पर कर लें लोग तो बहुत बड़ी बात होती है. That's where we are. So advanced computing, if you look at the hardware, even if you take the latest NVIDIA, 80,000 connections deal with a huge research work. That's where we are. That's why I said, whatever we feel that it can do faster, now see where we are, number one. And the most important part is, you also study synapse. जब neural network पढ़ते हैं ना तो synapse. Synapse is a connection where the input and comes. And the beauty in the human brain is the electric pulse gets converted into chemical at the synapse, then because there is a gap. Input comes from here, output goes here, there is a gap. The synapse is a gap there. So the electrical signal cannot go here because of this gap. So this will convert into a chemical one, then chemical will flow, then this again gets back to electrical. Look at, see now, because of that, one thing is, this is how the spikes are generated, and I'll only talk few things and then correlate with that. Let me put this, the beauty of human brain. If you look at this diagram, this is my neuron and this is outside. And the most interesting part is, these are channels. Channels, they are closed and they get open. Voltage gated, when the voltage difference is, they will get open. What do they do? Two elements are very important for human brain. One is potassium, one is sodium. Are very important. इसलिए डॉक्टर के पास जाइए सोडियम पोटेशियम कम नहीं होने देता है. जैसे होगा बहुत कहता बहुत खतरनाक लड़ाई है, right? And that's why people also talk at times because of the sugar and BP. Yeah, this is not a scientific proof, but this is what people guess कि BP इतने लोगों का सब नमक खाना कम कर दिए. And because of that, your potassium, sodium also decreases and लोगों को जल्दी भूलने की बीमारी लग रही. This is what people are thinking of. One of the reasons for dementia over the period could be the low intake of the salt because of the BP problem, low intake of the sugar because of the diabetes. Energy is not sufficient for the human brain. The human brain takes 20% of the total energy of the human. अब जितना आपका energy शरीर में 20% is taken by the human brain. It's a good amount of energy, 20%. And if your energy levels are low, and the brain will work low. And what is happening here is, see, the important part is, if you look at that diagram जो आपने पूछा था, sodium allows the spike to go up, generate a spike, and potassium brings it down. Look at that. And that gives the time to, and if there is a potential difference, जैसे ही potential difference होगा तो ये open हो जाएगा, sodium will flow inside. So there's a lot of sodium outside, less sodium inside, there's a concentration difference. Therefore, sodium will flow inside, that will generate a spike. Potassium is more inside and less outside, so potassium comes out. So the ions keep on flowing from inside to a neuron, sodium and potassium outside. So the concentration difference will be balanced, and the potential difference, when they are equally balanced, then neuron is at rest. So every time neuron will try to come to an equilibrium. That's what the whole issue is. Now looking at this, I'll not go into that detail, much detail of that. And there are the movement. One of the interesting points is that if the concentration difference goes reverse, there are ion pumps. They will start pumping ions to a right direction. See, look at these pumps takes out of 20%, these pumps takes 50% energy. Because if you have to pump from low concentration to high concentration, you need energy to pump. So 15% out of that 20 is taken only for pumping ions. Now, what I'm trying to say from here is now, I'll not take much time. So that's what, if you look at this equation, what I'm trying to say, this is what a neuron will get from all other neurons, plus its resting potential. Bias जिसको आप वैसे कहते हैं, U rest is a resting potential. That's what you do, ANN, that is bias. W0, wait, right? And now, the beauty with the human brain is, the human brain has to make decisions in uncertain situations. Okay, this. So it makes decisions in a very uncertain situation and very noisy situation. If I get some information based on that, I have to make some information. And the important point is one of the data that human brain receives from the environment about an event. I see something, I hear something, and this may be noisy or very uncertain. But another part of this is human brain already have some knowledge. And that we call a prior knowledge. I have a prior knowledge. जैसे कि आपने कोई किसी का बायोडाटा पढ़ा और आपने उसके बारे में बताया ऐसा है वैसा सोच लिया जब इंटरव्यू देने आया then based on the interview you update that knowledge. You might have performed good in the interview and you have different impression now. Oh, ऐसा लग रहा था बड़ा अच्छा है, he's a good candidate, right? So human brain has a capability to update the knowledge, but your neural network cannot do that. I'll come to the comparison, right? It updates its knowledge, the prior knowledge based on the new evidences. So it's a Bayesian network, right? That is not part of that, but and so therefore this leads to some basic questions. And what is the mechanism that human brain uses for making decisions under uncertainty? In what way the human brain represents existing knowledge? जो knowledge है वो कैसे represent करते हैं? उसकी ऐसी कोई memory तो है नहीं जैसे यहाँ आपके वो बने हैं chips हैं वहाँ तो chip है नहीं, right? So that's what's important. And how does brain update this knowledge? So one of the view is, which are not very scientifically proven yet, but say that probably the human brain represents information in terms of probability distributions. Because in a probability distribution model, you have to only remember the parameters, nothing else. Based on the parameter, you know the distribution. So this is one, it's followed, and a lot of people work on that. And second is for operation of knowledge, it's follow Bayesian network. That's what 2 points count. But if you look at this, this is the diagram where we say how the Bayesian computation goes, but I'm not going into that detail. But if you come to the deep learning now, I'll try to correlate and then see. It's a very powerful tool, no doubt about that. But its basis is ANN, right? Deep learning has a full basis is artificial neural network, and that is most likely supervised learning. That's how deep learning works. And you keep on adding more layers, and then you say that you're increasing the complexity, and a function is function of some other layer, function of some other layer. And one of the, how this deep learning came is also done in taken inspiration from human brain. Or cortex is the latest recent development in the human brain is जो हमको अगर brain का map दिखाते ऊपर layers दिखती है ना, that is called cortex. It has 5 layers. And these 5 layers, ऐसा नहीं कि न्यूरॉन अलग-अलग है, न्यूरॉन सेम है, इसलिए कभी-कभी आदमी कॉमा से भी बाहर निकल आता है. The beauty of the human brain is some of the neurons may replace some other neurons who are dying, which are dying. कई बार आपको चोट लगी, कुछ न्यूरॉन में चोट भी लगी, खराब भी हो गए थे. Probably some other neurons may take place. So therefore you can come back. But it does not always happen. That's the problem. इसलिए कुछ लोग नहीं आ पाते, उनका replacement होता ही नहीं. So, and because these all 5 layers have same neurons, and this 5 layer context is a vertical context, 1 layer, 2 layer, 3 layer, यहाँ पर neuron ऐसे ऐसे लगे. This is the notion we have taken from that. There can be multiple layers in a neural network, then we call it deep. यहाँ तो 5 से ज़्यादा होते हैं, लेकिन brain has only 5 layers, right? And so this is one taken from there. And one of the things we miss most of the time is, अब किसी ने कोई deep learning वो कहेगा कि जी बस the features are not manually done, features are automatically. यही से शुरू करते हैं. That's how we start with. This is what is called representational learning. Look at the second part. It's called representational learning, and it has also come from the human brain. How do we represent the stimulus we have achieved? अगर हमने कोई चीज देखी, how it gets represented in a human brain. An image cannot be, मेरे दिमाग में कोई box तो बन नहीं रहा है. The moment I see a box, it is not a box here. That means the moment I take my input, my codes in the eyes connected with the nerve through nerves to the human brain, and they are connected to different neurons. Some neuron record its size, some will its color, some may do something else, So it's an ensemble of multiple neurons which record this information. So therefore this becomes a vector. Mathematically it becomes a vector. Right? X1 is size, X2 is color, X3 is scene. Look at the vector. That's what people represent mathematically. And look at that's why the neural network also has same vector as an input. If you say vector as an output, then we say it is a neural, it's a deep neural. And that's how it goes. ये बहुत ऐसा diagram नहीं है कि मैं कोई नया diagram वो कर रहा हूँ, but this is one of the good diagram which we study. It, if you look at this representation learning, and this here you only learn features, you learn features as well as you do your classification. But not going in detail of that, I compare it in 5 minutes. Before that, what deep learning can do, what it cannot do, quickly. Most tasks that require mapping from input vector to output vector. And though we don't get output as a vector, but if you look at that each individual element of the vector is divided at different neurons. So we convert into scalars, but if you look at it totally, it is a vector. That are easy for a person to do rapidly, but since it has to be done for larger of time, so humans cannot do, probably it can. Given sufficiently large models or data sets and training examples, that's what the deep learning has come up. But other tasks that cannot be described as a that shades a vector with other vector, and that cannot be done by deep learning, number one. And number two is, as the human cannot think, that cannot be done by also. That's not important here. The important point is, let me put it this way. The differences, quickly in 5 minutes, is this. See, look at this. In deep learning, what you do is the connection between neurons are fixed after design. एक बार हमने न्यूरल नेटवर्क बना दिया तो कौन सा लेयर से कौन सा न्यूरॉन किससे होगा वो फिक्स हो गया. Then you cannot change that, right? And कितने न्यूरॉन लेने हैं, that is also fixed. Then you train. After that you start training and then testing. But the brain doesn't do that. The connections between neurons may change over lifespan. Connection बनते रहते हैं और बिगड़ते रहते हैं. बिगड़े तो भूल गए, बने रहेंगे तो आप याद रहेंगे. So the brain has a beauty of the connections are formed and deformed, right? So if you look at this, it cannot truly represent the human brain that way. And secondly, neurons may die over the period. जैसे जैसे हमारी एज ग्रो होती है, हमारे न्यूरॉन दाई भी खत्म होते हैं, इसलिए हम अल्जाइमर, डिमेंशिया, बहुत सारी चीजें होती. बट पहले कहते थे कि न्यूरॉन्स आर नॉट रीजनरेटेड. अभी कुछ साइंटिफिक रिसर्च कह रही कि दे आर आल्सो जनरेटेड. अभी बहुत बड़ा प्रूफ नहीं है, but now the theory coming and the scientific evidences are coming that the neurons are also generated after some age. नहीं तो 8-9 साल के बाद न्यूरॉन नहीं बनते. That is what the initial was about. This is one difference. And other difference you go in deep learning, only this depends on the synaptic input. That means what I am saying is, एक न्यूरॉन से जो आउटपुट आया और दूसरे को इनपुट किया. So the input to a neuron is depending on the what is coming from the synapses. And activation function is the one which provides a non-linearity in ANN, right? In deep learning. But if you look at the brain, it depends on the synapses as well as the neuron itself. एक तो जो synapse से input आ रहा है, दूसरा जो neuron के भी अपना potential difference होगा, उससे भी आपका output generate होगा. So in actual neural network, the output of a neuron depends on the input coming from other neurons plus the neuron itself. But in ANN it is not. It is only from the input. Then you apply the nonlinear function activation. And here no activation function that way if you look at it. The nonlinearity is built in. The moment there's a potential difference, if you look at decay, so it is built in part of the neuron itself. It is not that forced artificially that you bring nonlinearity. All activities in the human brain are nonlinear by default. And third part is, weights of synapses are fixed once you train it. एक बार अगर न्यूरल नेटवर्क को ट्रेन कर दिया, वेट आपके कंप्यूट हो गए, फिक्स हो गए. एंड उसी वेट पर आपको टेस्टिंग करनी है. आपको दोबारा कुछ करना, फिर ट्रेन कर लो. But that doesn't happen. And the same input and same weights give you the same output. अगर एक इनपुट पर वही वेट है और वही इनपुट आ रहा तो आपको वही आउटपुट मिलेगा अगली बार में. But that doesn't happen with the human brain. The beauty with the human brain is weights of synapses varies with the time. That we call a synaptic plasticity. हमारे जो synapses जो बीच का कनेक्शन है उनकी स्ट्रेंथ भी घटती बढ़ती ओवर द टाइम. इसलिए आप बार बार अगर पढ़ेंगे तो आपको याद हो जाता है ना. Because the synaptic strength increases. And बहुत दिन तक नहीं देखेंगे तो आप भूल जाते हैं. So more you are experienced and more you see something, more you read something, your connections become stronger. So therefore you remember it. Let's see your connections. So the synaptic the connections between neurons are dynamic in real brain, right? And the other part is the same input and the same weight may not give you same output. That's also a beauty of human brain. But it depends on other things as well.
Same input and same weight give the same output. इसमें तो नॉन लिनियर लगाते हैं ऐसा ना हो.
नहीं वो तो आप ठीक कह रहे हैं, बट आपने नॉन लिनियरिटी लगाई तो ठीक है. बट हम ये कह रहे हैं कि ब्रेन में आपके वेट भी चेंज होते रहते हैं. सिनेप्टिक स्ट्रेंथ घटती बढ़ती है ना. एक्चुअल ब्रेन में तो चेंज होते रहेंगे, राइट. उसके बाद न्यूरॉन पर आके वहां भी नॉन लिनियरिटी लगी, न्यूरॉन का आउटपुट नॉन लिनियरिटी वहां भी लगी, लेकिन वेट फिक्स नहीं है आपकी. यहाँ आपके अगर फिक्स होंगे तो फिक्स होंगे. Therefore, the same input, even same weight भी होंगे, तो न्यूरॉन का पोटेंशियल बदल सकता है ना. न्यूरॉन जो है उसका भी अपना पोटेंशियल बदलते ही जो है टोटल आउटपुट बदल जाएगा. So it may not give you the same output, even if the input and the weights are same. Because neurons have its own potential difference that also adds to the output. Yeah, and in deep learning, when you train to optimize parameters, do you think the brain does optimization of the parameters? इतना टाइम नहीं है. 400 मिलीसेकंड सब कुछ हो जाना है, राइट. कोई चीज देखी उसका रिस्पॉन्स भी हो जाना है 400 मिलीसेकंड. इतना टाइम थोड़ी कि सब ऑप्टिमाइजेशन करेगा. It cannot do optimization. And will take a lot of data and then optimize. No. एक दो स्पेक है उसी पर डिसीजन लेना है, लेकिन 10 स्पेक आएंगे फिर ऑप्टिमाइज करेगा. It cannot do that. And second is there is no back propagation in actual neuron. वो नहीं कि यहाँ से करेगा फिर आउटपुट पर जाएगा फिर वो क्या कहते हैं डेरिवेटिव निकाला रिस्पेक्ट टू वेट्स एंड देन करेगा देन भेजेगा देन न्यूरॉन विल टेक अ डिसीजन. हो गया तो हो गया आदमी का दिमाग. So there is no back propagation in actual human brain, no optimization of parameters in human brain. But here you look at all deep learning depends on the optimization of parameters and mostly back propagation. See, look at the huge difference between, and that's it. Right? Time भी मेरा हो गया and see the conclusion is, though we have made a significant progress in deep learning, but still far behind the functions of the human brain. Look at the differences, the huge differences between, and we have to achieve a lot. That's what it is. And the processing capability, this is not sufficient in spite of the good hardware. अब कितना भी अच्छा टेंसर फ्लो, इतने हमारे टेंसर्स बने हुए हैं, they do fast matrix multiplication, but still, if you look at the large brain connections, we will not be able to deal with it. So, therefore, more research is needed to deal with that. Thank you. This is what I made slides from these books. If anybody needs reference, you can read these books and you can also listen to some books lecture by pull from Gessner on neuro. If you are interested in computational neuroscience, you can read some lectures, and this is a good book for. Also, the kind text which is the good film. Anybody has to understand deep learning. This is a beautiful book, MIT Press, by Ian Goodfellow. इसको जरूर पढ़िए.
Any questions are not. you have any query, any question
Anyone has
from
any questions,
the audience?
but please ask.
Any query, any questions?
सर ये जीपीटी जो है ट्रांसफॉर्मर विद अटेंशन ये डीप लर्निंग का एक्सटेंशन बोल सकते हैं या ब्रेन से रिलेटेड है या बिल्कुल अलग डोमेन
See, one thing you have to understand is what has come in the deep learning is also inspired by brain. So these neural networks are an inspired network, inspired by the brain. Brain में कुछ चीजें होती है उसके हिसाब से इसको बनाया, but it does not represent the brain activities. Total mimic नहीं है, but it has taken. So the attention mechanism is also taken from the human brain.
ट्रांसफॉर्मर मॉडल
Because transformer model is, if you look at attention part is the most important in transformer model. So that has been taken from the human brain. If you look at some neurons are very active because when you want to focus something, you pay attention to something. Activities of some of the neurons will be different than other normal neurons. Therefore, there you are focused more.
जैसे हमको नॉस्टैल्जिया बोलते हैं 10 साल पहले आपका क्लास सुना वो याद आ गया दैट अटेंशन इज देयर
Yeah, attention.
लॉन्ग स्पैन का अटेंशन
That is what we are talking of the memory. One of the research areas there is a memory, short-term memory, long-term memory. How long you can keep? So if the neural connection is strong for a very long time, then you can recall.
दैट इज आल्सो
The
रिलेटेड
synaptic plasticity जो मैंने बात की थी, कितना connection is strong है. A very strong connection will keep your memory for a longer period of time. तो इसलिए आप जिसको आप जितनी बार देखे होंगे किसी चीज को, वो बहुत लंबे समय तक याद रहती है. हमको काउंटिंग कितनी बार से याद कराया होगा घर में, इसलिए आप जिंदगी भर नहीं भूलते, because the connection related to the counting is so strong, you cannot forget.
वो भी ब्रेन से कंपेयर होता अच्छा रहेगा वो स्लाइड्स वही रहे
तो मैं अभी उतना synaptic plasticity पे गया नहीं, मेमोरी फिर वो अलग टॉपिक हो जाता है. So you have to need sort of things. ठीक है.
Thank you so much, sir, for your session. It was truly an enriching one. Now, shortly, we will have our next keynote speaker, Mr. Praveen Kumar Pal, who will be joining us virtually after some time.
क्योंकि मेरा भी वही मानना है मैं भी अगर इसके कमी मैं आर्टिफिशियली लोग कोग्निटिव स्ट्रेस आता नहीं है चीजें ऐसी है Thank you, sir. Listening to your seniors professor. नहीं उसको अभी कहाँ काम उसके क्लास थोड़े से ना अभी है बाकी लेन के भी छूट रहा है क्या ना
You want to read something?
बैठ जाओ बेटा बैठ जाओ कुमार सर
अरे तो बिजी
मैथ होगा नहीं मैथमेटिक्स जरूरी है न्यूरल नेटवर्क में तो न्यूरल नेटवर्क में तो परसेप्ट्रॉन होता है न्यूरॉन परसेप्ट्रॉन होता है
सर वो ही कनेक्ट कर दो उससे हो गया सर टाइम टेबल के लिए
क्वांटिटी में फोटो वो सब कर रहे थे मैं तो सर बहुत छोटा मुंह बड़ी बनाना चाहता हूँ जितना भी मैंने दिखाया सर मैं नहीं लगा
ऑनलाइन कर देंगे
क्या होना चल नहीं रहा कर दिया वाईफाई नहीं चलेगा
माइक्रोसॉफ्ट टीम जो है ना काफी बेहतरीन दिख रहा है गूगल सबसे सिंपलेस्ट कम स्पेस वाला बोल दो सर
उसका है कौन सा
क्या एनएस कैपिटल एक कैपिटल है इन्वेस्टर बाकी सब कौन जी है वन तो मैंने सब योजना से साफ से लेके कैसे एग्जाम आ रहा है लाइक भी कर